Hello, welcome back to Statistics and Mathematics YouTube channel. Please kindly subscribe to Statistics and Mathematics YouTube channel, okay? So today what you are going to do is to solve examples on discrete uniform distribution, right? So without wasting much time, let's dive into the question solving. So our question 1 here says, let the random variable x have a discrete uniform distribution on the integers 1, 2, 3, 4. Find the mean and variance of what x. So right now they have given us the consecutive integers, right? So here our a will be equal to 1 and our b is equal to what, 4, because we said that our a will be what, our lower bound or the lower limit, and our b will be what, our upper limit. And when you check this consecutive here, our upper limit is what, 4, and our lower limit is what, 1. That's the reason why we got our a to be equal to 1 and our b to be equal to 4. So now let's get back to the question solving. It says that we should calculate for what, the expectation of what, x. So expectation of x2, we know that is what, a plus b divided by 2, right? A plus b divided by 2. So when we come here, that is what I have done here. That one will be what, 1 plus 4 divided by 2, because we know that our a is equal to 1 and our b is equal to 4. That is 1 plus 1 divided by 2, and we get what? We go to our 2.5. And then our second example says, our second question says we should find the variance of what, x. And then we know that for variance of x is equal to b minus a plus 1 all squared minus 1 divided by 12, right? Already we know our b to be 4 and our a to be 1. All that we have to do is to just substitute the a and b inside the formula. And when you do the substitution, we are getting 4 minus 1 plus 1 all squared minus 1 divided by 12, which will give us 4 raised to the power square minus 1 divided by 12, where we get 15 divided by 12, and our answer is 1.25. So that is the solution to the first question. So our second question here says that the random variable x is equally likely to assume the values 1 over 8, 1 over 4, and then 3 over 8. Says we should find the expectation of x and the variance of what, x. So this is values that is being assumed for what, this random variables, right? Yes. So for us to be able to calculate for our expectation and variance, we have to get our a and b for the expectation. Okay, so we know that expectation of x is equal to a plus b divided by 2, and from this consecutive distance we have here, our a is equal to 1 over 8, and then our b is equal to 3 over what, 8. That is what we have here. So what that we have to do is to just add them. So we are going to get 1 over 8 plus 3 over 8 divided by 2, of which we are going to get 4 divided by 8 all divided by 2, and our final answer will give us what, 1 over 4, right? Yes. So we have gotten the expectation. What about the variance? Okay, so for the variance, we know that for the variance of x is equal to what, b minus a plus 1 all squared plus 1 divided by our 12. But you can see that from the definition that we defined in our first video on the discrete uniform distribution, we said that we use only this formula where a and b are our consecutive integers. But you can see clearly that this is not what, these values are not what, integers. So the formula that we are going to adopt is what, n squared minus 1 times what, d squared all divided by what, 12, right? Yes, that is what we have here. So this is the formula we are going to use. But note, our d here is equal to what, the common difference, right? Our d here is what, the common difference. So when you check the consecutive this thing, our common difference here is what, 1 over 8, because when you subtract 1 over 8 from 1 over 4, we are getting what, our answer to be 1 over 8. If you subtract 1 over 4 from 3 over 8, we are getting 1 over 8. So you see our common difference is what, 8. Okay, that is the only thing we have to know here, because our n is just simple. We know that our n will be 3, okay, because we are having n values. So here we are getting our n squared minus 1 times d squared divided by 12, and our answer will be 3 raised to the power square minus 1 divided by 12 times 1 over a squared, which is equal to a divided by 12 times 1 over 64, which is equal to 1 over 96. So that is the solution to that question. Okay, and then question 3 says a random variable y is a uniform distributed with a mean 0.15, with value 0.15, 0.16, 0.17, 0.18, 0.19, and then it says we should find the expectation and what variance for the random variable y. Okay, and then we know that our values that we have here, they are not what consecutive what integers. These are rational numbers. Okay, so for the expectation, it's surely going to work for a plus b divided by 12, but for the variance you cannot use the b minus a plus 1 all squared plus 1 divided by 12, right? You cannot use that formula, but rather we're going to use the n squared minus 1 times d squared divided by our 12. That is what we used earlier. Okay, yes, so here we know that our a will be 0.15 and our b will be what, 0.19, and our n will be equal to 5 because we are having 5 observation here, and our d is equal to 0.01 because when you subtract the value from each other, the common difference is what, 0.1. okay, so here the expectation would be what, a plus b divided by 2, which will give us 0.15 plus 0.18 divided by 2, and our answer will give us 0.17. That will be what our expected. Okay, and then for the variance we are saying that variance of y will be equal to n squared minus 1 times d squared divided by 12, of which you know our n squared, our n was 5, so when you square it you are going to get 25 minus 1, and our d2 was what, 0.01, and when you square that you are also going to square this one and then divided by 12, and then this will be the result, and our final answer will be 0.0002, right? This will be what, our final answer, and this will be the last question on this slide. Okay, so he said suppose that x has a discrete uniform distribution on the integers 0 through 9. Determine the mean and variance of y is equal to 5x and compare with those values of what, x. Okay, so that is what we are going to calculate for. Okay, and then you see we are having integers, and that integers, they are moving from what, 0 to 9. So that means they are going to get 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. These are the values that we have. So with this one, we know that our a will be equal to 0 and our b will be equal to 9, as it has been stated on the slides, right? So if you want the expectation of x, is just a plus b divided by 2, of which you are going to get our final answer to be 4.5. Okay, and then our variance here, we can use this formula because our observation here are integers. So here we are going to get 10 squared minus 1 divided by 12, of which our final answer will be what, 8.25. But we know that the x was defined, and then we were told that we should determine the mean and variance of y is equal to 5x. Okay, not the variance of x and then y. Okay, so here we know that in our basic statistics we learned that our expectation of y, which is equal to expectation of 5x, is equal to 5 times expectation of what, x. Okay, so with this one, our expectation of y will be giving us what, 5 times what, the expected value here, which will give us 4.5, and we are going to get our final answer to be 22.5. And then for variance of y is going to be variance of 5x, which will give us 25 times variance of x, and we are going to get 25 times our value here, which is 8.25, and our final answer is 206.25, right? So that is the solution that we had here, 206.25. That will be our final answer. So please, this is Statistics and Mathematics YouTube channel, right? Please kindly subscribe, like and share, and don't forget to leave your comment if you have any question, and then click on the notification bell for any video. From here we are going to treat what is termed as Bernoulli distribution. So stay tuned. Bye. Have a lovely day.